Right, Edx M3 Jun 2010, question 6, variable acceleration question, where acceleration here is a function of time. So pause and read the question. It's a straightforward, reasonably straightforward question if you're confident at integrating. We've got the acceleration is a function of t, so we're going to use dv by dt as the expression for acceleration. Let's just copy that down. dv by dt equals minus 3 over t plus 1 squared. Okay, and we've got to show the expression that they've got there for velocity. So a straightforward integration, hopefully. Let's do that then. So v is minus 3 times the integral t plus 1 to the minus 2 dt, which, check the integration yourselves, comes to 3 over t plus 1 plus a constant. Now in the question they tell us that t equals 0, v equals 2. So putting that in, that gives c equals, and to check this yourselves, gives c equals minus 1. So v is equal to 3 over t plus 1 minus 1. And that's the first part. That's part A done for 5 marks. And now we've got to find, for part B, the distance of P from O when P is instantaneously at rest. Let's go on to the next page for that. Have some more room. So far we know V equals 3 over t plus 1 minus 1. We've got to find the distance that it's covered to the point when it's instantaneously at rest. Well, let's put v equals 0 so we can find the value of t. Well, v will be 0 when 3 over t plus 1 equals 1, and that'll be when t plus 1 equals 3, in other words t equals 2 seconds. So that's the time, and we want to find the distance. So velocity. Velocity is rate of change of distance, or strictly speaking rate of change of displacement. So we've got dx by dt is 3 over t plus 1 minus 1. So we need to integrate that now then. So x equals the integral of 3 over t plus 1 minus 1 dt. Now we can either integrate indefinitely and put a plus c in and then find plus c, find the value of c, or it's probably simpler and more direct to integrate between limits, because we know that the times concerned are from t equals 0 to t equals 2. We want to find the distance covered in that time interval. So x is, well, it'll be 3 ln t plus 1 minus t from 0 to 2, which comes to 3 log 3 minus 2. And that as a decimal is 1.3 meters. And that's it. As I said, you could have integrated and found the value of the constant and then put t equals 2 in, but I think that putting the limits in is quicker. So the marks, allocation of marks were like this. Let's just have a look at it. We've got an M1 for writing the dv by dt expression, an M1A1 for integrating with a plus and having a plus c in there, and then another M1A1 for evaluating the value of the constant and getting the correct expression for v. And then for the rest of it, finding the value of t when it's instantaneously at rest, M1A1 for that, carrying out the integration, putting in the correct limits, and finding the correct final value, 2 method marks and 3 accuracy marks without subdividing them. Basically, there was a method mark for attempting the integration, and a method mark for putting in the correct limits, accuracy marks for getting the integration right, the 3 log t plus 1 minus t, and for putting the limits in. Okay. So there's some more information about the Further Math Support program, and thank you for listening.